Mistakes, mistakes, mistakes. We see them every day, everywhere in our lives, especially in software, we can say. And in software, they manifest themselves in the form of software bugs or defects, however we call it. And it can be often quite overwhelming because we've got a lot of those bugs in software. But let me quote Al Franken here. So he said that mistakes are a part of being a human, and appreciate your mistakes for what they are. Precious life lessons that can only be learned the hard way. So you know what? I completely agree with that. I agree that there's something to learn from each one of the mistakes that we make. And let this be my promise for you. In terms of software, I think we can learn those mistakes that are induced by software bugs in a still hard but a little bit more enjoyable and efficient way. So let this be my promise for you that at the end of this presentation, we'll know how to do this. We will know how to take out lessons from software bugs with a bit more fun and a bit more efficiency. So with that bold promise out of the way, let me introduce myself. Hello, I'm Szymon Sadowski. I'm a lead software engineer at Sabre, where I spend my efforts developing the monorepo approach for my company, which is one of the main areas of focus currently for me. And it is a real pleasure and real honor to meet all of you, and thank you for being with us here on the Friday afternoon, where the weekend is already starting. So let's get back to this idea from the beginning of this presentation, that there's something to learn from each one of the software bugs that we encounter on our way. You know what? Let's challenge that idea. Let's put it to the test. We will go through 3 external debugging stories that I found online, and together we will try to think about a life lesson or some experience, some conclusion from each one of them. So the first one is the 500-mile email story. This one comes from the guy named Trey Harris. And he had a job of running an email system for the campus. And one time he gets a call from the chairman of the department, where the chairman says, we've got a problem. In our department, we cannot send emails to destinations that are farther than 500 miles. And Trey says, what do you mean? The emails doesn't work like this. The geography isn't the limiting factor in email, but the chairman says that indeed they cannot send emails farther than 500 miles, and he even ordered one of his geostatisticians to plot a map with the destinations where they tried to send an email, and the map clearly showed that the radius above which they cannot send emails is give or take 500 miles. And chairman also said that this problem started happening when one of the consultants came in, and on the central server of this campus, he did some patch, but he claimed that he didn't touch the email system. So Trey came down to the chairman office, and he started checking for himself. So firstly, he tried sending email to Memphis. So it's worth to note that the department was located in North Carolina. So when he tried sending email to Memphis, which was 600 miles away, because it was give or take more than this 500 miles, the email delivery failed. He tried New York, which was a little bit closer, 420 miles, and it was a success. Providence, 580 miles failed, and Princeton, 400 miles success. So at this point, Trey started to question his own sanity because he knew that the emails don't work that way, and that the geography shouldn't be a limiting factor. So he quickly got over it and started debugging. So he logged into the server. He checked the configuration file of the sendmail, the sendmail.cf file, and all the properties that he prepared were fine. So as a matter of fact, a few weeks ago, he upgraded the sendmail to the version 8, and there was some new features for new long descriptive named properties. And he was a good admin, so he used this newest version of sendmail and used the nice long named properties. And he looked at it, couldn't find anything. As one of the attempts, he tried telnetting into the SMTP port, and he was presented with a banner of SunOS. So at this point, he had some clue because SendMail wasn't owned by SunOS. So why all of a sudden it started appearing here? And all pieces of the puzzle came together to him. He checked the version of the SendMail, and it turned out that the version was SendMail 5 instead of the SendMail 8 for which version he prepared the configuration file even. So it turned out that the consultant, when he upgraded the SunOS, as a side effect, the downgradation of SendMail happened to SendMail 5. And it so happened that this was a modified version of SendMail, which could kind of read the new properties of SendMail 8, or could mostly read it, because when it encountered some properties that it didn't recognize, it defaulted to some value. And in this case, it defaulted to, for a property to connect the timeout of the connection to the remote SMTP port was by default set to 3 millimeters. So if we can do a quick calculation, because we need to assume that the network connection was very ultra low delay on this campus. So the connection speed was approximately speed of light. So we'll do, if we do a simple calculation, if we convert 3 light milliseconds to miles, it turns out that it's around 558 miles. So that was the mystery of the 500 email problem. And do you have any ideas what we can learn from such a case? Any ideas? So to me, the learning from such a story is that it's always good to check the versions of the software that may influence your system. So for example, one time I had a case where one of the developers in my team had a problem with Tomcat configuration. And I was led to believe that it was problem connected to the fact that she had a Mac and I had a Windows system, but it turned out that it was just a different version, and when we installed the same version as I had, everything ran smoothly. So that's it for the story number 1. The story number 2, the observer effect story. This one comes from Andreas Zeller. So he had a program and the program crashed. So far, so good. But he wanted to check something, so he introduced a print statement in the program to check some variable, and the bug was magically gone. So this, for you interested in quantum mechanics, this might sound a little bit familiar to the observer effect, which states that whenever you introduce observation to your system or measurement, it always influences the system in some way. But we're not dealing with quantum computations here, not at least for the next 10 years or so, when we invent the fully functional quantum computer. So he started debugging further. He removed the print statement, and the bug still was gone. So after long debugging, it turned out that the problem was connected with the linker. So the linker had two modes. One, the incremental mode, where the linker would just link in new changes, and the non-incremental mode, where the linking would be done from scratch. And the bug only manifested itself in the non-incremental mode. So as a resolution, he had to put a comment in the build script to change some options so that the linking would be done twice, and always the incremental mode would be at the end, and the bug wouldn't happen. So any ideas, maybe, what can we take out from this story? So one learning that I think we can learn from this is to be aware of certain classes of categories of bugs. In this case, after a quick Googling, you would see that those kind of non-deterministic bugs are often called Heisenberg bugs, after the Heisenberg cat or the Heisenberg work in the quantum mechanics, but it's just a nomenclature. So those kind of bugs are very often connected to some memory addresses shifting, to linkers and timings in parallel processing. So it's important to be aware of those kind of bugs because whenever we see some non-deterministic bug like this, be sure to check those things, right? The memory addresses, the linker, and the timing. Okay, the story number 3. So this is also an interesting one. So this is the story about a guy who couldn't log in when he was standing up. So this one comes from, I don't know the author, but it comes from Reddit. And there was a system admin working at a heavy machinery factory. And one time he gets a call from the office worker. The office worker says that he cannot log in when standing up, but he can log in when sitting. And this was kind of ridiculous. So the system admin goes like this. He thinks that this is one of the calls from the user who has no clue what he's doing. So he starts asking like, what do you see on the screen? Have you restarted your computer? Have you really, do you really remember your password? But the office worker says that that he's sure that that's a problem that he's having. So the system admin gets down to the place where the office worker was sitting, and he asks the office worker for the password. He types it in, it's a success, and he says, do you see? Everything is fine. And the office worker goes like, yeah, I told you. Now log out, stand up, and try again. So the system admin obliges and does exactly that. He logs out, he stands up, he types a password, and it's a failure. And he thinks that, okay, that might be just a bad luck. So he tries again, and still, this is a failure. He tries a bit more times, a couple more times, and he even tries his password, and he can log in to his account when sitting, but not when standing. So at this point, they're making quite a show for everyone around, and the people start gathering and trying their password, and some of the people can also log in when sitting, but not when standing. And interestingly enough, some of the people could log in both those cases, sitting and standing. And after long debugging session, they found the problem. So the problem was like this. Some guy, as a joke, pulled out 2 keys from the keyboard and switched their places. And this was the joke that he made. And most of the guys in this factory, they were good at typing. So when they were sitting, they weren't looking at the keyboard, and just by muscle memory, they were typing their password. But when they were standing up, it was something that they weren't used to. So they had to look at the keyboard, and this made them press the wrong keys. and that was the mystery resolved. And do you have any ideas what kind of life lesson we can take from this? Okay, I don't see an idea, so I'll just suggest my idea. So my idea is to always validate your assumptions. So whenever you have a bug, even a simple one where you cannot get to the bottom of the problem, you can start validating the even most basic assumptions. Like in this case, one of the assumptions that could be validated was to see if the keys were placed correctly in the keyboard. And in a more realistic scenario in software, we can check, for example, if we are believing a program is doing something, let's say because a comment says so, or a variable name says so. Let's validate those assumptions because often they are misleading us, and they might be the root of the problem. So that does it for the external stories. And as one more lesson from this that I'd like to share is to, as you could see from all of those stories, we were able to take some lesson to gain some value from this. So please always have this attitude when you are investigating some problem and you are getting frustrated because this is long and tiresome. Keep in mind that always at the end we'll learn something, and along the way we will also learn a lot more about the system that we are working with. We'll develop some new techniques. So it's really good to have this kind of attitude when we are investigating problems in our code. Okay, so now we can go to my personal stories that I wanted to share, the debugging stories. So the first one is a case of Maven build issue. So one time I took over a large Java monorepo project. And it was very complex. It consisted of more than 500 modules. And when I was trying to build this project, just with Maven, the simplest way is to run the Maven install command. It gave me such an error. So by the error, when I researched it, the duplicate project exception, it basically happens where some module is included more than once into the build tree. So basically it's a scenario where you have some kind of a conflict in your build. And it was really not that easy to find those two conflicting import paths because in the project of that scale, there can be countless import paths, like many modules can import one another, and there can be conditional setup where some modules are included conditionally. So it was really a non-trivial task to right away tell what the issue is. But I did some research and formulated such a plan of action. So I really like doing everything via debugger. So I found the plan of action like this, where I can download the Apache Maven source code to my computer. I can open it up in my IDE, in this case IntelliJ, and rather than running this simplest command to build mvn install, I can run mvn debug install, which will open up a port for me to which I can attach my debugger process, and from my IDE I can see what's going on under the hood. And before we do that, I wanted to discuss a few useful debugger capabilities. So I really recommend to stay on top of your game if it comes to debugger, because there are new features implemented to the debugger constantly, and those are just a few that I wasn't aware of until recently, and they are very, very valuable and very good for many cases. And I wanted to focus on two particular capabilities. The first one being the exception breakpoint. So hopefully, if we manage to get to the live session of debugging, we'll use that one. So when you are using a debugger and you want to investigate some exception in your code, this capability allows you to stop at the place where the exception is thrown. And many times we are adding our breakpoints just in the catch clause, and the advantage of the exception breakpoint is that it stops at the place where the exception is thrown. So you can see all the runtime information, the entire context, the values of the variables, and so on. And the second one is the drop frame capability. I like to call it the time machine capability, because essentially it allows you to drop a frame or more frames from the stack and go back to the parent calling function. So essentially you can go back in the execution flow, and it's especially good if, for example, you're debugging something and you see that you are already too late. You wanted to check something, but you are further into the execution flow. And in this case, you can use the drop frame to go back to the parent function, set up a breakpoint in a place where you wanted to check something, and resume the execution. And in this case, stopping at a place where you wanted to see something. So before I used this, I used to, like when I concluded that I'm too late in the execution process, I resumed the program, waited for it to finish, and started over, and it was really time consuming. So drop frame really saves us a lot of time in this case. And we'll try to go to the live session if it will be possible. So I'll try to quickly switch to a YouTube video. Okay. Okay, looks like we've got it. So let me just... So it will be a short clip. So as a first thing, I wanted to demonstrate that we indeed get this exception that we are talking about. In this case, this duplicate project exception. And like I discussed, we run this Maven debug command, which allows us to attach to the port that were specified. And here we are doing this exception breakpoint, like I mentioned. So this duplicate project exception, and this will allow us to stop the execution at the point where the duplicate exception is thrown. So we are running the debugger, and here, as you can see, we already stopped at the place where the exception is thrown. And here we will do a simple search. So as you could see, one second, the conflicting project ID here on the second one from the bottom is called com testvares labs SDKs API adapters. So basically, we need to get to the bottom of how this project is included twice in the build tree. So here I am expanding the list of all projects or all modules that are being built. I will do a simple search for this API adapters modules that we are investigating. And as you could see, we've got two of those, one at index 216 and other 247. So here we are investigating the stack trace to see the place where the projects are not yet gathered, because we essentially want to see how the projects are gathered and how this module is included twice in the build tree. We want to get to the bottom of this. So here we are using the reset or drop frame capability. We went back in the execution flow, and we are investigating. So we first need to find a place where basically projects are being included to the build tree. So we are investigating here a little bit. We are getting into the under the hood of Maven, so really, really low-level stuff, some build functions of Maven. I will just skip a little bit. So we are placing some breakpoints which allow us to see a little bit more what's going on in this build process. Okay, skipping a bit. Okay, so here finally we found a place where the POM file is the file which defines a Maven module. So here we found a place where POM files are added to the list of the results. So this is what we may be looking for, because we essentially want to find how this module was included twice in the build tree. So here I am doing a conditional statement to only stop the execution at the time where API adapters is included into the build tree, because this is what we want to find, how this API adapters was included twice in the build tree. So like this, we've got the first hit, and on the left is very interesting stack trace. Like we can see on the bottom, it shows us the POM file, and here I am noting down the first import path. So by analyzing this stack, we are essentially finding this information that we didn't know from the start. What are the two import paths? So this is how we gather it, and it's gonna be the first one. So we noted down the first one, and here we resumed the execution flow and got to the second case where the API adapters module was included. So as we can see, this is another completely separate import path of including this module. So that is it. By the means of debugging the insides of Maven, we are able to find the information how the module was included into the reactor tree. And at this point, to fix that issue, we can remove one of those import paths, ensuring that nothing is breaking, and so on. Okay, so that was it for the story number 1, and I will go back to presentation. So case number 2. So that is a case that I had where we're using a tool called Kaniko, and this is a tool for building container images from Docker files inside of Kubernetes cluster. It might sound super convoluted, but long story short, it was used in the build process of our applications. And one time we had to add some kind of security policy, which was suggested by Red Hat and enforced by our security department. And we had to add, for example, this capability drop. So for example, drop the kill capability or some other capabilities, and also stuff like ensuring that containers are running in a non-root mode. And after we added this, it turned out that some of the applications failed to build. So in isolation, we checked each policy that we added one by one, and it turned out that the culprit was this kill capability. And it was really interesting why this tool needed the kill capability, which basically says that you cannot kill not your own processes. So why this tool needed to have this capability. And as a plan of action, I did some research, and a simple approach, or a little bit more brute force approach, was to attach the tool called strace to the process of building the application. And this strace tool is a tool which allows you to listen to system calls. So in this case, if we're investigating sending a kill signal, the strace will allow you to see that. But I was a little bit hesitant to use that tool because this is as low level as you get debugging system calls, and it's really scary because it produces a little too much for a human to read. But I managed to find the root cause because of strace. When I delved deep into the large wall of logs, the problem became apparent. So the problem was that when we are building this image of application, we had a run command, which executes a shell command. And when this A command under the hood triggered some process B, then at the end of the execution, when the build is done, then the Scanico tool needs to kill all of the remaining processes. So it had to kill the process B as well. And at this point, it was having to kill a process that didn't own the background process. So the resolution was to mitigate that and remove such statements from the build. Not sure if we have time for live session, so probably we need to skip, but at the end, I want to summarize, we're getting to the end. So some of the debugging principles that we reviewed here. So the first one is to always understand the system. As you could see, the research gave us a lot of info up front, how we can debug some certain issues. The second one is to always plan your sessions because it allows you to spin up new ideas whenever you're planning your process of debugging, and also allows you to be organized because at the end you have the record of what worked and what didn't work. And the last one is the problem isolation. So always try to think in terms of specific components, how you can narrow down the problem to a specific component. And just a simple scenario, if we have a web application where we see that some characters are displayed incorrectly and the assumed architecture is like one of the bottom, then we can start checking if the data is correctly saved in the front end. Then we'll check if it arrives in the correct form in the gateway service. Maybe the business service is doing some processing which corrupts the data. Maybe CRUD service receives an incorrect encoding header, or maybe database has some option set, some collation option set, which corrupts the data. At one point, you will find where the issue happens, so you can focus your search inside of that area, and this allows you to quicken your debugging process. So, before we end, for key takeaways that I wanted to present. So always try to gather knowledge from every case that you are investigating, even if it's a really frustrating, pesky software bug. Try to learn something from it, and do not get discouraged, because keep in mind you are always getting something out of it. And the second one probably would be to not be scared by the scary tools like strace. So in my experience, I was scared at first, but at the end of the day, they are not that scary. And I think we can even use nowadays the ChatGPT or other models to explain us a little bit more what those scary tools are outputting and help us understand the output better. And the last one is to have the courage to look down under the hood, as we saw in the case of Maven investigation. Sometimes the answer is already there somewhere deep into the code, but you just need to reach for it and find it for yourself. So with that, thank you for staying with us on this Friday afternoon. You're amazing, and it was really an honor to meet all of you, and thank you.
Thank you, Szymon.